A 100-meter steel cable that helps support the Golden Gate Bridge is 72 millimeter in diameter and composed of 100 steel wires twisted together. Oh, wow. So the 100-meter will be the length of the wire. 72 millimeter is the diameter in the, I'm gonna make a notion for myself that this is in millimeters. We need to convert it to meters. And it's composed of 100 steel wires twisted together. Approximate this as a single uniform steel cable that has a mass density. Okay, so this is a mass density of 7.86 times 10 to the 3 kilograms per cubic meter. So this is the raw density, mass density. The wind generates in the cable a vibration that creates a wave that travels down down the cable at 380 meters per second. So this is the speed of the wave. What is the tension in the cable? So it's asking us to find force of tension. Okay, so let's pull out the information. So we have the length of the cable equals 100 meters. We have the diameter of the cable, 72 millimeters, which is 0.072 meters. And then we have the density, rho, equals 7.86 times 10 to the 3 kilograms per cubic meter. Then the speed of the wave is 380 meters per second. We want to find out force of tension. Okay, well, we know that the speed of wave depends on the tension in the cable, and it is expressed in an expression for the wave that equals square root of force of tension divided by the linear mass density. So from here, I can find the force of tension equals V squared times mu. Now, I have the V, but I don't have the mu. Instead, I have the rho. So how can I get mu from the mass density rho? Well, let's start with the definition of the rho, which equals mass per volume. And the volume is the length times cross-sectional area. And that cross-sectional area will be pi r squared. Now, if we take a quick closer look, so mass per length, it's our mu actually. And then I can represent the r in terms of the diameter. That's the diameter over 2. Now let's plug everything. Then considering this stuff, I can find, rewrite the mu, or the rho equals mu over pi d squared over 4. So from here, I can find the mu equals rho pi d squared over 4. Now for the mu, let's plug in the values to calculate the numerical value for that. For rho, I'm going to put the 7.86 times 10 to the 3 kilograms per cubic meter times pi and times 0.072 meters squared divided by 4, which when you plug it into your calculator, you will get 32 kilograms per meter. Now I can take this value and plug it into my expression of the force of tension. So let's write this in a different place with the numbers in. So I can say force of tension equals, so the V is of 380 meters per second squared times the mu is of 32 kilograms per meter. And if you punch this into your calculator, you'll get 4.62 times 10 to the 6 newtons. Wow, that's about 4.6 million newtons. Wow. So to compare, to understand the amount of force, well, one apple, falling apple, is a kind of 100 newton, the weight of an average apple. Well, I hope you enjoyed this. Thanks for watching.